Hi, this question is taken from JEE Advanced 2018 from its second paper. So it is basically MCQ question, multiple choice question. It can have more than one correct answer. So the question is basically from the topic inverse trigonometry. So let us go ahead and solve this question. But before going to the solution, I would recommend all of you to pause this video at this moment and give this question a try. So for a positive integer n, so there is a positive integer n, define fn. So there is a function fn whose domain is 0 to infinity and range is r, as fn is a function of x is j is equals to 1 to n tan inverse of 1 by 1 plus x plus j and x plus j minus 1 for all x belongs to the whole domain 0 comma infinite. Now here the inverse trigonometric function tan inverse x assumes values in minus pi by 2 and pi by 2. So tan inverse x lies in the principal interval. Alright, now let us go ahead and find out what fn of x is actually. Fn of x is sigma j is equals to 1 to n tan inverse of x plus, so this 1 in the numerator can be written as x plus j minus x plus j minus 1 by 1 plus x plus j into x plus j minus 1. So this is the formula for tan inverse of a minus tan inverse of b. So if you see the formula for tan inverse of a minus tan inverse of b, it will be tan inverse of a minus b by 1 plus ab. Alright, so now fn of x is equals to sigma j is equals to 1 to n. According to this formula, it will be tan inverse of x plus j minus tan inverse of x plus j minus 1. Alright, so this is the fn of x. Now let us put the values. If we put j is equal to 1, it will be tan inverse of x plus 1 minus tan inverse of x plus j equals to 2, tan inverse of x plus 2 minus tan inverse of x plus 1 plus tan inverse of x plus 3 minus tan inverse of x plus 2 plus and so on tan inverse x plus n minus tan inverse of x plus n minus 1. So tan inverse x plus 1, tan inverse x plus 1 gets cancelled. Tan inverse x plus 2, tan inverse x plus 2 gets cancelled. So this tan inverse x plus 3 also gets cancelled. This also gets cancelled. Now we are left with tan inverse of x plus n minus tan inverse of x. So this is fn of x. So we found out what fn of x is. So this is fn of x. So fn of x for all x belongs to 0 comma infinity. This is the domain given in the question. So this is a very tricky question. The options are framed in such a way that almost everyone commits a mistake over here. If you check the first option, it will be j is equals to 1 to n tan square fj of 0 is equals to 55. Fj of 0, you can find out fj of 0 from this. Alright, if it is f1 of 0, you'll put n is equal to 1 and x is equal to 0 in this expression, and you'll find out f1 of 0. And similarly f2 of 0, f3 of 0, all of that. when you do the calculation, you'll get the value as 55. But to find out f1 of 0 or f2 of 0, you should not put x is equal to 0 in this equation, sorry, in this function, because this function is only defined for open interval 0 and infinity. So 0 is not included in the domain of the function. So you cannot find out f1 of 0, f dash 1 of 0, all these things from this function. So, but if you directly blindly put the values into this function and calculate this expression, it will give you 55 and you will mark A as the correct answer, which is wrong. So most people will get negative marks in this question because of this. So in the exam pressure or that environment, you'll not be noticing all these things. You'll go and blindly put the values into the function and then you'll try to mark the options. That's what most people do. But this question proves why you should pay attention to the domains and codomains given in the question. So option A and option B are directly eliminated, so we cannot even find out those quantities. So option C, let us go to option C. For any fixed positive integer n, limit x tends to infinity, limit x tends to infinity, tan fn of x, tan of fn of x. We have to find out this. So limit x tends to infinity, tan fn of x is tan inverse x plus n minus tan inverse of x. So tan inverse x plus n is some angle and this is some angle. So this is in the form of tan of a minus b. So the formula is tan a minus tan b. So tan of a is tan inverse of x plus n, tan a minus tan b by 1 plus tan a tan b. So for your understanding, I'm writing all of this, so you can directly write all of this stuff. So limit x tends to infinity. So this is x plus n. The interval is the principal interval, it is given in the question, and this is x by 1 plus x plus n into x. This end, this x gets cancelled. So limit x tends to infinity, n by x square plus nx plus 1. So this will be what? When x tends to infinity for a positive integer n, the denominator tends to infinity, so this limit will be 0. So option C is not correct. Option C is not correct. Now let us check option D. Secant square fn of x. So the same limit, limit x tends to infinity, secant square fn of x. We have to find out this. So limit x tends to infinity, secant square theta is 1 plus tan square theta. So this is 1 plus tan square fn of x. So we already found out tan fn of x tends to 0. So tan square fn of x tends to, so this is limit x tends to infinity 1 plus limit x tends to infinity tan square of fn of x. So this is same as limit x tends to infinity tan of fn of x whole square. This term, this is 0, we already found out here. This is 1, so 1 plus 0 is 1. So option D is correct. So the answer to this question is only option D. So this question proves, again I'm emphasizing on the fact that you have to carefully look at the domains and codomains given in the questions.